All right, guys, this is the last related rate problem I'm going to look at. It says a 5-foot tall person is walking away from a 20-foot tall lamppost at a rate of 2 feet per second. Assume the scenario can be modeled with right triangles, so similar triangles. At what rate is the length of the person's shadow changing when the person is 14 feet from the lamppost? First thing I want you to notice is that they're walking away from the lamppost. So I'm just going to go ahead and draw this scenario. So you've got a 20-foot tall lamppost, and you have a 5-foot tall person, and that person is walking away from that lamppost. So I'm just going to label this. I can label this X, and I can label this Y. All right, hopefully you notice that there are some similar triangles here, and that's what I'm going to use to solve it. It's not just one right triangle, so I'm not going to just use the Pythagorean theorem for this. All right, so let's see. My big triangle would be 20 with a base of x plus y, and my small triangle would be 5 with a base of y. So if I were to set up a proportion, I would say that 20 is equivalent to 5 and x plus y is equivalent to y. Well, there's my formula. So let's do some cross multiplying, and then we can do implicit differentiation. So I'm going to get 20y equals 5x plus 5y. I notice there's a y on both sides, so I'm going to subtract 5y, and then that'll give me 15y is equal to 5x. All right, now I can take the implicit derivative of this function with respect to time. So the derivative of 15y would be 15. Since the variables don't match, I'm going to have dy dt. The derivative of 5x will be 5, but with respect to with respect to time, it would be dx over dt. Okay, now I need to go back and look at the original problem because I need to figure out what I'm actually solving for. All right, so with the original problem, it says, at what rate is the length of the person's shadow? Well, this is the person's shadow right here. So y, dy over dt is what I'm basically asking to find if the person is walking away at a rate of 2 feet per second. So if they're walking away, this rate is what's increasing. This distance that they're walking away from the lamp is increasing. So dx over dt would be 2 seconds. All right, so let's plug that in. Dx over dt would be 2 feet per second. And then you want to solve this for dy over dt. So I'm going to get 15 dy over dt is equal to 10. And then to solve this for dy over dt, I'm going to just divide by 15. And so that'll give me the derivative of y with respect to 10. 10 over 15, that reduces down to 2/3. So it would be 2/3 feet per second, or if you wanted to write as a decimal, 2 divided by 3, that would be 0.67 feet per second. So in other words, their shadow is increasing at a rate of 2 over 3 feet per second, or 0.67 feet per second, whichever way you want to look at that.